It's getting busy at the end of the semester now.
Yeah.
Okay, so we're going to do a couple of problems where we use concentration as a conversion factor. So remember, concentration is the amount of one thing divided by another thing, and of course that is what conversion factors look like, one thing divided by another. So let's look at the first problem here. It's how many grams of sodium hydroxide would you need if you were asked to make 75 grams of a solution that is 14% by mass sodium hydroxide. Okay, so first of all, let's just write down what the conversion factor is. So 14% will be 14.0 grams of sodium hydroxide divided by 100 grams of solution. Okay, so that's the conversion factor. And of course, we're given 75 grams of solution. All right, so it's rather obvious to see, just by coincidence, we have grams solution here and we have grams solution here. So all we have to do is multiply the two together. Okay, so 75.0 grams of solution multiplied by the conversion factor as this way. And the answer is simply 75 times 14 divided by 100. And so that is going to be 10.5. Okay, so 10.5 grams of sodium hydroxide. So 10.5 out of 75 is sodium hydroxide, so that means the rest of it is water, and so that's going to be about 64.5 grams of water. All right, so the next problem will be using molarity as a conversion factor, and it's how many moles of hydrochloric acid, or HCl, are in 250 milliliters of 2.5 molar hydrochloric acid. We're going to do the very same sort of thing. We're going to write down the conversion factor first, which is this. And so 2.5 mole divided by liter of solution, 1 liter, and it's HCl. All right, so that's the conversion factor we know. And let's write down what we're given. And we're given the volume of solution. Now, that's 250 milliliters. We need liters, and so let's go ahead and convert milliliters to liters, and so you should be able to do that. And that is 0.250 liters of solution. And again, it looks like by coincidence we have liters of solution and liters of solution here. So all we have to do is multiply these two, and the units will cancel. So starting with 0.250 liters of solution, then multiply it by the molarity. There's only two significant figures here. And so 2.5 times 0.25, that should be 0.625, which we ground off to 0.63 moles. Okay, so there could be all sorts of variations on this problem. One would be, how many grams of HCl would we have? Well, we just take the moles here and convert to grams. Or we could do other sorts of things, but this is actually a very important use of molarity. So we could actually write a little equation down that the concentration times the volume of solution equals moles. All right, So this it has to be in molarity though. And this is exactly why the molarity unit is so useful. It's because it allows us to directly convert a solution to a certain amount of the solute. So if we need a certain amount of the solute, all we have to do is know what the concentration is, know how much volume we need to measure, and measure it out, and presto, we have it.